So let's see this GATE computer science question. A nice question. Now let's solve this. What this question is saying. First you understand. So JK flip-flop we are converting to XY flip-flop. If you notice in this question, this is the JK flip-flop. We are converting this JK flip-flop to XY flip-flop. And this is the combinational circuit. So basically in this question, what we are doing? We are converting JK flip-flop. In this question, what we are doing? We are converting JK flip-flop to XY flip-flop. To this XY flip-flop. This JK flip-flop we are converting to XY flip-flop. Okay. Now let's solve it. So first and this is given to you. State diagram is given to you. For this circuit, state diagram is given to you. Can anyone tell me this circuit is JK flip-flop or this circuit is XY flip-flop? This entire circuit is JK flip-flop or XY flip-flop. Remember, this entire circuit is XY flip-flop. This is your XY flip-flop using JK flip-flop. This is your XY flip-flop using JK flip-flop. So ultimately, this is your XY flip-flop. So this state diagram is given to you for XY flip-flop. This is the state diagram of XY flip-flop. Is this clear? This is the state diagram. This is the state diagram of XY flip-flop. Of XY flip-flop. Okay. Now, once this state diagram you have, this is the XY flip-flop. Now you have to find the answer. So you have to find out what is this combinational circuit. This combinational circuit you have to find out. You have to find out basically what is the equation for J and the equation for K. This is what you have to find out. Equation for J, equation for K. So this is what you have to find out. So how will you do? Now, let me tell you the method number 1. Inefficient method. Method 1 is what? This is conversion method. Convert JK flip-flop to XY flip-flop. Let's convert JK flip-flop to XY flip-flop. Let's convert this. Okay, this is the conversion method. This method is inefficient for this particular question because you can check out the options. The method number 2 will be check out the options. Okay, anyway, let's see the method number 1. That is, let's convert this JK flip-flop to XY flip-flop. So first you understand the XY flip-flop. This is the, okay, so this XY flip-flop is given to you. What this XY flip-flop is? X, Y, and this is your Q, N. So when both are 0, 0, then tell me, when both are 0, 0, when X and Y both are 0, 0, then what is happening? Can anyone tell me? When both are 0, 0, when XY both are 0, 0, when XY both are 0, 0, then no change. Yes or no? Look at the state diagram. Look at the state diagram. When XY are 0, 0, when the input XY is 0, 0, this is your input XY. So when the input XY is 0, 0, then no change. Then there is no change. No change or retain. This is your retain. When XY is 1, 1, then what is happening? Sorry, 0, 1. When XY is 0, 1, for the 0, 1 you are toggling. You are toggling. For the 0, 1 you are toggling. Next, for 1, 0. For 1, 0 what is happening? For 1, 0 what is happening? For 1, 0. For 1, 0. Again toggling. Again for 1, 0 is also you are toggling. For 1, 0 also you are toggling. For 1, 0. And for 1, 1 what is happening? For 1, 1. For 1, 1 retain. For 1, 1 you are retaining. For 1, 1 you are retaining. So this is your XY flip-flop. So let's convert the JK flip-flop to XY flip-flop. See, this question you can solve. Let me tell you, this question you can solve by at least 4 methods. I will tell you all the 4 methods. This question you can solve by at least 4 methods you can apply in this question. Okay, so the first method I am telling you, that is conversion of JK flip-flop to XY flip-flop. So let's convert. So if you want to convert JK flip-flop to XY flip-flop, then what you need to do? Basically, this JK flip-flop you are converting to XY flip-flop. So what do you need to do? This JK flip-flop you are converting to XY flip-flop. Some circuit you will create. Some circuit you will create. This XY. So you will write this J. You will write as a function of what? As a function of XYQ. And this K you will write as a function of what? As a function of XYQ. Can you check it? Can you do it? XYQ. So let's solve it. So this J we have to write as a function of XYQ. This K we have to write as a function of XYQ. So this is your XYQ. Okay, so we have to write the j and k. So as a function of x, y, q, this j we have to write as a function of x, y, k, x, y, q, and this k we have to write as a function of x, y, q. So first I will do what? First I will create the truth table. This truth table I will create for the xy flip-flop. So let's create the truth table for xy flip-flop. So tell me, for the xy flip-flop, this is the retain. This is also retain, this is also retain. Both are retain. Means both are retain, unchanged. Both are retain. And this is toggle, this is toggle. This is toggle, this is toggle. So 1 0 1 0 for the xy flip-flop. Now, so from these two, I will find out what is j comma k from the excitation table. So in the jk, if you go from 0 to 0, then what is the excitation table of jk? If you go from 0 to 0, then either this combination or this combination, either this combination or this combination. See, either this combination or this combination. It means 0 comma don't care. It means 0 comma don't care. If you go from 1 to 1, then either this combination or this combination. Means don't care comma 0. Means don't care comma 0. If you go from 0 to 1, then either this combination or either this combination or this combination. Means 1 comma don't care. Means 1 comma don't care. If you go from 1 to 0, then either this combination or this combination. It means don't care comma 1. It means don't care comma 1. If you go from 0 to 1, then either this combination or this combination. Either this combination or this combination. Means 1 comma don't care. 1 comma don't care. If you go from 1 to 0, then either this combination or this combination. Means don't care comma 1. Means don't care comma 1. If you go from 0 to 0, then either this combination or this combination. Means 0 comma don't care. Means 0 comma don't care. If you go from this combination to this combination, from 1 to 1, then either this combination or this combination. That means don't care comma 0. Don't care comma 0. So that's it. Is this clear? Is this clear? See, you don't have to by heart the table. See, very simple. For example, did you understand what I have done? Did you understand? For example, 0 to 0. For example, 0 to 1. For example, 0 to 1. 0 to 1. What it means? Either you do 1 1 or you do 1 0. Either you do 1 1 or you do 1 0. Either you do 1 1 or you do 1 0. So basically, it means it is 1 comma don't care. Okay, so this is your table. So from this table, let's find out the equation for j. This j I have to write as a function of x, y, q. So let's find out x, y, q. This is x, this is y, this is q. Okay, this is your x, this is your y, this is your q. And similarly, this k also x, y, q. So this is also x, y, q. So this is also x, y, q. So this is the area of x, this is the area of y, this is the area of q. Now let's find out. So you can notice this will be don't care 1, don't care 1, don't care. Okay, so this will go like this. So the table you can fill, basically the table is 0 1. So all things are don't care actually. 0 1, this is don't care. 0 1, this is don't care, this is don't care, this is don't care. All these are actually don't care. Okay, all these are don't care. Next, after this, all these are don't care. 0 1 2 3 4 5 6 7, all these are don't care. And where is 1? 1 is for 2 comma 4. 2 comma 4 is 1. 0 1 0 1 2 3 4. Okay, so this will be finally what equation you will get? What equation? You have to do this. You have to do this. So that will be, this will be yx bar, this will be yx bar, and this will be xy bar. Yx bar, xy bar. So what is j? So what is j? J is a x exclusive. J is x XOR y. This is j. And what is k? And what is k? So let's find out k. So what is k? K is don't care, don't care, don't care, don't care. And where is 1? 1 is for 3 and 5. For 3, 5. 0, 1, 2, 3, 4, 5. Okay, so finally, this will be what? This will be x bar y. This will be x bar y, and this will be x y bar. So both are x XOR y. Okay, so this k is also x XOR y. So both are x XOR y. J comma k both are x XOR y. So what is the answer? J comma k both are x XOR y. What is the answer? The answer is option D. Okay, the answer is option D. Did you see that this method is very idiotic method for this question? Did you understand this? First you tell me, did you understand this method? Basically we are converting JK to XY flip-flop conversion. Basically this method means basically we are converting this JK to XY. Okay, so this method is idiot. This is an idiotic method. This method is idiotic. This method 1 is time taking. From the GATE exam point of view, this method 1 is inefficient. Inefficient method. This is very much inefficient method. Okay, so we can do other analysis. So don't do this. What is method 2? Method 2 is just check. Okay, just put values and check it out. So method 2 means put xy values, put x comma y values, put x comma y values, and verify with state diagram, and verify with state diagram. Verify with state diagram. Let's see this method. Verify with state diagram. So now what I'm going to do, I'm going to use another method. Let me see. So see, very simple. Tell me, when xy is 0, 0, then what should happen? Now what I'm doing this. When xy is 0, 0, what should happen? When xy is 0, 0, then what should happen? Then state should not change. Tell me, just tell me, when xy is 0, 0, then state should not change. State should not change. So what should be j comma k? What should be j comma k? Please understand. Please understand. See, when xy is 0, 0, when xy is 0, 0, then state should not change. When xy is 0, 0, state should not change. Now, if I apply x equal to 0, y equal to 0, then state should not change. So what should I get here? So what should I get here? Tell me. If I apply 0, 0, then state should not change. So if I apply 0, 0, okay, then what should I get here? I should get 0, 0. Yes or no? If I apply 0, 0, then I should get 0, 0 because state should not change. State should not change. So I should get 0, 0. So which option is gone? If I apply x0, y0, then state should not change. It means if I apply x0, y0, then this j must be 0, this k must be 0. So which option is gone? All the options are gone. Answer will be option D. All other options are gone. Yes or no? Can you notice all other options are gone? See what I'm saying. Please understand. If x is 0, y is 0, if this x is 0, y is 0, then what should happen? State should not change. This state should not change. Okay. So if x is 0, y is 0, then my state should not change. So if I apply x0, y0, then after this combination circuit, I don't know what is this combination circuit. I don't know what is here. I don't know. But after this combination circuit, what should I get? What should I get so that state should not change? What should I get so that state does not change? What should I get so that state does not change? This is the idea. What I'm asking that when x equal to y equal to 0, then what should be j comma k? What should be j comma k so that state does not change? State not change. So tell me what should be j comma k so that state not changed. State does not change. So state does not change. So there should be 0, 0 so that state does not change. Yes or no? Tell me, anyone has any doubt in this? So you can notice if x and y are 0, 0, then state should not change. This is x 0, 0, x y 0, 0. So state should not change. It means what should be this j? This should be 0, and this k, this also should be 0, so that state does not change. If your state is 0, it should remain 0. If your state is 1, it should remain 1. State should not change. So it means your jk must be 0, 0. Your jk must be 0, 0. So when x 0, y 0, then j must be 0. So I can say that when x is 0, y is 0, then j must be 0, k must be 0. But what option A is saying? Option A is saying, now option A, what option A is saying? When x is 0, y is 0, then what option A is saying? Option A is making j equal to 1, k equal to 1. Yes or no? Option A is making j equal to 1, k equal to 1. Option B, what option B is doing? Option B is doing j equal to 1, k equal to 0. Option C, what option C is doing? Option C is doing j equal to 0, k equal to 1. And what option D is doing? Option D is doing j equal to 0, k equal to 0. So these options are gone. These are eliminated. These options are eliminated. So finally, if all these options are eliminated, then this has to be the correct answer. Then option D has to be the correct answer. Okay. So this is another method. Is this method clear? What is another method? What is another method? Another method is just compare this xy with jk. Another method, method number 3. What is the method number 3? Method number 3 is compare xy flip-flop with jk flip-flop. Let's compare xy flip-flop with jk flip-flop. What this xy flip-flop is doing and what this jk flip-flop does, let's compare them side by side. So what this xy flip-flop is doing, tell me. For 0, 0, what this xy flip-flop is doing? For 0, 0, it is not changing state. For 0, 0, it is not changing state. For 0, 1, it is toggling. For 1, 0, it is toggling. For 1, 1, it is not changing state. What jk does? What jk does? What will jk do? When this q will happen for jk? For jk, this will happen in this situation. When this q will happen for jk? When this q will happen for jk? When this q bar will happen for jk? When this q bar will happen for jk? Is this clear? So we are comparing jk and xy. This is another method. Method number 3. What this method says? Compare xy flip-flop with jk flip-flop. Just compare them. Xy flip-flop with jk flip-flop. This is xy flip-flop. Okay, so you can notice when both are 0, 0, unchanged, state is not changing for xy flip-flop. When both are 1, 1, state is not changing. State is not changing. Now you can notice. This will happen for jk flip-flop when? This will happen for jk flip-flop when they are 0, 0. This will happen for jk flip-flop when they are 0, 0. This will happen for jk flip-flop when they are 1, 1. This will happen for jk flip-flop when they are 1, 1. Now can you find out the equation? Now what the question is asking? The question is asking j as a j in terms of x comma y. Now can you find out j in terms of x comma y? So what will be j in terms of x comma y? What will be j in terms of x comma y? So j in terms of x comma y, that will be x XOR y. And k in terms of x comma y. K in terms of x comma y, that is also XOR. This is your method number 3. All the 3 methods, are they clear? The same question you can solve by many different methods. Which method is your favorite now? Method number 1, 2, 3. Which method is favorite? Of course, method number 2. Of course, method number 2. But see, in the GATE exam, you should apply the best method. In the GATE exam, either you can apply method number 3 or you can apply method number 2 in the GATE exam. In the GATE exam, don't apply method number 1. Okay? In the GATE exam, don't apply method number 1. But you should understand every method.